Okay, great. Wait, but is that with the ATA and you saw for those, or you saw for the C1s?
The C1 and the C2.
Okay.
That is how you find a particular stuff.
Okay.
Sort of. I mean, it depends on which method you're using. So if you're doing the undetermined coefficients, it's one thing. If you're doing the parameters, it's another thing. And so it just depends.
Oh yeah.
I mean, it's really just semantics, though. If you know how to get the right answer, then that's great. Now, whether it's named particular or general or whatever, let's see what.
Oh, that's what I wanted to do.
I don't know how many people are going to come because I was looking at the grade book a little bit ago, and it looks like about half of the class has already taken the chapter.
Okay.
And they're not going to be coming.
Probably.
Yeah. I haven't taken it yet, so, and I don't really have any specific questions, but I figured I would see what other people have asked and see how that went.
Yeah, sure. I mean, other than that, I can just browse through the homework and try and figure out other questions so we can at least look at them.
Yeah, that sounds like a good idea.
I'm down.
Natalie, you don't have any specific ones you want to look at?
Like as far as then have I went over the review yet?
No.
Or do you want to do stuff online?
The review. Yeah, if you have some of those questions. I don't have a copy of it with me. It's locked away in my office, but if you just want to type out the questions, we can look at it.
Okay.
There should be a chat thing somewhere.
Different.
And you should be able, there's a whiteboard feature on here. I'm just not sure if it's a two-way thing, but that might be something we can figure out, maybe. I think if you do the, share content button, no, it's not that one. Somewhere else.
Annotate. This is request control. I don't know what this is. I mean, I can't.
And there's a chat feature too, so worst comes worst, you can just try and type it in there, I guess.
I know, right?
Yeah, I don't see a whiteboard thing anywhere.
Yeah.
Are you in the desktop version?
I am, yeah.
Or okay, because I'm in the Chrome version and I'm actually not seeing it. I saw it before though. Let me see. I'm gonna see if I can try to open it in the actual app and see if that does anything different. So I might disappear. I don't know.
I might disappear. Let's see how.
So it looks like I'm gonna have to disconnect here and rejoin there. So I'm gonna try to do that and see if that works.
All right, we'll wait for you.
Yeah.
Okay. There we go.
Did you find it?
The problem looks like that now is not really the best format. But you know, everything is, I don't know.
Yeah, everything's crazy.
Yeah, it looks like that.
Yeah? Okay.
Yeah.
So there was a couple different ways of solving questions like this. And it kind of just depends how you feel comfortable doing it. But this is one of those equidimensional problems. It's just not quite like it yet until you multiply everything by x squared.
Oh, yeah.
Oh, okay.
Now we have it in that case, right? They have x's instead of t's, but it's still the same thing.
Okay.
And then, so with this, right, this is where we want to do that characteristic equation. That's why we have the equidimensional case. So the characteristic equation is this. Just make sure when you go to take the test, that you have this equation like in front of you. So it's online, which means I can't stop you from using your notes and stuff, but it is timed. So don't waste a lot of time looking through your notes to find these equations. But just trying to have it in front of you and easy to find.
Right. I almost forgot about that equation, but yeah, it is an important one.
1, C is -4, and then the C is 6, so just typing it all in.
Oh, yeah.
This is -4 minus 1, so -5, and plus 6. And hopefully that can be factored. It kind of looks like it could. R minus 2 and R minus 3. Yeah. Which gives us the two solutions, 2 and 3.
Gotcha. Okay.
So you're going to have to, again, like have the notes in front of you at least. So for this equidimensional case, it's very different depending on your solution. Here we have the two solutions, which doesn't sound too bad. So with the two solutions, your solution is going to be in the form C1 t to the first plus C2 t to the other one. And that's it.
Gotcha. Okay.
Now, if this was a double root, then this would be a lot different. And then if these came out to be complex roots, this would also look quite a lot different. And if one has a natural log in it somewhere, sometimes you find something like that.
Yeah, I remember that. Okay. I haven't had a problem with that in a while.
Yeah.
Yeah, the answer's there, right? Is that the answer that they got on the practice thing?
They actually have the plus 2/3 at the end as well, so they
Was there some initial conditions?
it just says find the general solution. But
You're at number 3, right?
I don't know why I have to put 2/3 at the end.
I don't know. I wish I had grabbed that before I took everything out of my office.
This is, you said this is the equidimensional one, right?
Yeah, equidimensional because you have the second derivative and then the independent variable squared. First derivative and then a linear term and then just the function itself and then just a constant.
Oh, right, to get all, okay, to get them, because like at first, look at it, at first it doesn't really look like that.
Oh, yeah, not until you multiply everything by the x squared to get rid of all the fractions.
Okay, so that makes sense. Ooh.
I'm trying to look and see. I'm looking right through my notes trying to see if we've got an example that can explain where that 2/3 comes from.
I have no idea.
That was 4.7, correct? That was that chapter?
I believe so, yeah.
Yeah.
Yeah, that was the one with, yeah, that's a damping. That's a damping as well.
Oh, okay.
What did you say?
I think I figured it out.
Oh, okay.
Because we just solved it when it's set equal to 0. We didn't solve it when it's set equal to 4 here.
Oh,
We have
okay.
a homogeneous solution. We still need to figure out the
Non-homogeneous.
Right. Okay. Gotcha.
So to find that, because all of this comes out to be equal to a constant, all you do is just plug a constant into here, which I know doesn't seem like it's going to do anything because the second derivative of a constant is just 0. The first derivative of a constant is 0. Basically, all you're going to end up with is just 6, whatever that constant is equal to 4. So then, of course, when you divide that, the 6 over to the other side, that gives you a third.
So you're saying you're plugging some arbitrary constant into there?
Yeah.
Into like, so you take a constant and then you set like you find the second derivative and then find the first derivative and then put the constant in there, like C?
Yeah, just for this example. So because it's all equal to a constant, and because this is all equidimensional, which basically means that whatever it's equal to, your solution is going to be in the same form. So because it's equal to a constant, plug in a solution that is also a constant.
Oh.
It needs to be.
So if it was some constant, you would plug in like something squared or something.
If this has, like an x here, like a 4x, then you would try a linear thing.
Okay, that makes sense.
If we didn't have a 4x, we would try something like, a1x plus a2, something like that.
Gotcha. Okay.
That makes sense.
So then once you have that means that your actual solution is adding the two things together, right? If your actual solution is the general solution, I keep putting T, these should be X. Plus the particular solution, which is just the fraction 2/3. That's where that 2/3 is coming from.
All right, that makes sense. Okay.
And I Googled around, I found the thing.
Can you plug that constant back into the original equation or the one with
the one where we had multiplied through?
Okay, yeah.
I mean, it doesn't matter. Like, you could have plugged it into this.
Yeah, you get the same thing.
As well, but
okay.
This is the one I used.
That makes sense.
Good. Is there any other ones? Any other examples from that practice that you want to get?
I think we went over some of them in class, but I can't remember because it's been so long.
Well, I think next class period. I don't remember. Maybe we did go over some of it.
You probably.
Out the day of the test, or if we were let out the day before.
No, we were let out the Thursday before because we were supposed to have it that Tuesday, but then on that Monday they were like, nope, no school.
Right. Okay.
Oh yeah, I remember that.
Yeah.
I was like, oh my God, this is going to be tragic.
Yeah.
You know, I'm not going to lie, before this class started, I actually got in my car and drove like 11 to school and then came back home. But I had to get out the house. I was like, oh no. I was like, this is
mindset, going to school mindset.
Yeah. I had to get into the mindset of actually going to class.
Right.
Yeah.
Oh man. That was crazy. Okay, so let's see if I can. So that was an equidimensional one.
Yep.
I'm trying to look. I think I've got. Yeah, I have an outline of like all the stuff that he went over like the last class before. He doesn't show out all the stuff. So I mean, if we just want to go through, like I had a star by equidimensional. I'm trying to see if I started anything else.
Like last class or like last webinar?
Yeah, the last like class.
Okay.
March 12th to be specific.
That was so long ago.
Oh man.
Yeah, that was a very long time ago.
Yeah.
Yeah, really has. Could we do one with like the variation of parameters? I don't know. I think that would be like section 4.6 is what I have it here. I don't know how it is on the homework though.
Yeah.
Because that's where you have the crazy V's and all that stuff.
Yeah.
I don't like that one.
Yeah.
Okay.
So I want to go over it.
I'm just looking at the practice thing here.
Yeah, I wasn't sure if there was one.
This one
Number 4 looks good.
parameter. You want to do that?
Yeah, okay. Yeah, sure. I don't want to, but I think it would be beneficial.
Okay. So let's try it. Y equals prime plus 4y is equal to 2 tangent to 2x. All right, cool. Yeah, so if you have a problem like this, there's two different major things that we've done. We've done the undetermined coefficients method, and then we've done the variation of parameters method. You cannot because of this tangent. The only way you can do the coefficients is when you have polynomials, e's, and then cosines and sines. Everything.
So, I'm sorry, say that one more time.
Okay, so for the undetermined coefficients, you can only have polynomial, e stuff,
Right.
or cosine or sine. And that's it.
Okay.
So if the function on the right-hand side is anything else besides this stuff, you have to use the variation of parameters.
Okay.
That's what we're going to do these.
Variation of parameters.
Alright, so
And I remember before, there was, you had said like we could have a sine or a cosine, but not both, but then we did the superposition thing so we can have those added together on the left-hand side.
yeah, so that's a good question. So just bringing this back over here, number 5. Number 5, you would have to do this twice because of the plus sign, and if there's two terms.
Okay.
The first one, you would be able to do undetermined coefficients for. This one, though, because of the x in the denominator, you would have to do variation of parameters.
Okay.
And then by the superposition, you would add those two solutions together to get the final solution. So you kind of like what you were saying, Emily. If on the right-hand side you had cosine plus sine, you would have to do them separately, and then superposition add the solutions together.
Gotcha.
All right, so back to this one, y double prime plus 4y is equal to 2 tangents. Step 1, and the first thing that you always do is you want to find the general solution. And then probably a better name for this, the homogeneous solution.
Okay.
This is doing the auxiliary stuff.
Right.
So this is just going to be r squared plus 4 is equal to 0. Subtract the 4 over and take the square root. We're going to get 2 solutions here. Plus and minus, not I, 2i. Because we have complex solutions for the auxiliary, that means that our homogeneous form or general form, whatever you want to call this, is going to have the C1. It's going to be, remember it's e to the alpha, cosine and sine of the beta.
Right.
We do not have an alpha. Our alpha is 0, so we're not going to have an e term. So we're just going to have cosine and then the sine. Right, so again, complex solution, e to the alpha, but that's just 0, and then cosine and sine of the beta, which is the 2 here.
Okay.
So that's the homogeneous form. This would be the solution if there was no 2 tangent 2x on the other side. If this was just 0, this is the final answer.
Ours is unfortunately not that easy.
No.
I know.
All right, so next if we're doing the variation of parameters, the next thing that you want to do is you want to write out your particular form. The particular form is based on the homogeneous form. But instead of constants in front of the cosine and the sine, this is where we want to put those functions of t, and we call them v1 and v2. So this is v1 of t, and that's going to be on the cosine 2x, and then plus another function, v2 of t, that we're going to put on the sine 2x. The reason we do that is after we plug that back in, and you can skip all of those steps, you're going to end up with that system of equations. Might as well just have this written down somewhere in front of you when you go to take the pen. So it's v1 prime y1 plus v2 prime y2 is equal to 0. And then the other formula, v1 prime y1 prime plus v2 prime y2 prime. And that is equal to whatever the function is on the other side divided by a. Our a is just 1, which means that this is going to equal to the 2 tangent 2x. And now you want to solve this system. Plug in the y1 and the y2. y1 for us is cosine 2x. y2 is the sine 2x. So we still have the v1 prime, but now y1 cosine 2x plus v2 prime, where y2 is sine 2x. It's still equal to 0. So this is just copying the first equation down, right? This equation became this one. And then my second equation, v1 prime. y1 prime is the derivative of cosine 2x, which is negative 2 sine 2x.
Okay.
Plus v2 prime, and then the derivative of sine 2x is 2 cosine 2x. And this is still equal to the 2 tangent 2x of a.
This is the fun part.
Oh, go away. This equation became this one. This equation became that one. That wasn't worth it at all. All right.
Underline in different colors. That's what I do, like in my notes. Make it things straight.
Because the problem is that, like, I scroll up and down, so
Right.
my stuff was messed up.
Maybe you can change your text color or something. But anyway.
Is it bad? Oh, like this? Like change the green? Or yeah, that'd be a good thing. I'll think about that in the future. Now we have the system and we want to solve it. Usually what I do is I just solve for the v1 prime here. So we're going to subtract this whole term over and then divide by the cosine 2x. So it's going to end up being the negative v2 prime and then sine 2x divided by cosine 2x, that's the tangent 2x. Give me just a second. Closing my door. Okay. Good, so that's that one. And now we want to take this one and plug it into the second equation. So now it's going to be that negative v2 prime tangent 2x plugged in for the v1 prime times the negative 2 sine 2x, and then just copying the rest down. All right, and now we want to solve this for the v2 prime, which is fun. So first off, this negative sign and this negative sign are going to cancel each other out. 2x times sine of 2x isn't anything all that nice. I would probably just leave it like that for now. And then I have this v2 prime that I'm going to factor out of both of these terms. So I would write it like this. So we have the v2 prime, and we're going to factor that out. We have 2 tangent 2x sine 2x for that first term there. And then plus a 2 cosine 2x for the second term there. Still all equal to tangent 2x. I'm noticing that everything has a 2 in here. I'll probably just divide and get rid of all those 2's. And then I'm going to divide by this entire bracket. So that'll give me v2 prime is equal to, I have the tangent 2x on top, and that's going to be divided by the tangent 2x sine 2x plus cosine 2x. Like that. Now we want to clean this up a lot. And to clean this up, we're using some of the trig identities. I think the right thing to do would just be to change the tangent into sine over cosine.
Okay.
Then we're going to have fractions with cosines in the denominator, so I'm going to multiply everything by cosine 2x. On top and bottom. Right, so still have the v2 prime. When you multiply by cosine 2x onto tangent 2x, the cosines in the denominator cancel out. You're just going to end up with the sine 2x in the numerator. When you multiply by cosine 2x in the denominator, this is sine squared over cosine, and that cosine cancels out, so this is just sine squared. On the second term, you're going to be multiplying another cosine into here, so we have cosine squared. So your denominator is going to be sine squared plus cosine squared, which is just 1. So that awful looking thing here simplifies down just to be sine 2x.
Wow.
Now that's what v2 prime is. We also would want to go back and figure out what v1 prime is. But now that I have v2, I can just plug it back into the substitution I had here. So that means that v1 prime is going to be negative sine 2x tangent. Or, again, if you want to change it, negative sine squared 2x. And that's going to be divided by cosine 2x. That you can't simplify down, and I think you're just stuck with it.
Yeah. So, since those are the times, I remember vaguely that we have to integrate this now, maybe?
Yeah, so now let's find just v2. To find v2, we're going to integrate over v2 prime, which is sine of 2x.
That was loud.
So the antiderivative of sine 2x is 1/2 cosine 2x?
Yeah, I think so.
I think it's negative. Negative 1/2 cosine 2x?
Yeah, I think sine is positive.
Okay. And then v1, same kind of deal. That's going to be the antiderivative of, it jumped on me, of v1 prime, which is this awful looking thing. I don't know exactly what's the better way to write it to get the antiderivative. I'll just leave it how I had it up there. So just integrating over v1 prime. Does not look like a U substitution would work here.
Could you break it apart to the tangent sign?
Yeah, you could.
That makes it a little bit easier.
Maybe.
So yeah, we could think of it like this.
I don't have my integral table in front of me.
Yeah, I'm not going somewhere. Maybe. I think I'm over it.
I gotta find it. Oh, there's one. This one here, though. Yeah. Secant.
Did you break the invisible part?
Because these are multiplied, you couldn't. No.
And you still can't do a U substitution, can you?
Not with either of these, no.
Should we maybe use an infinity with the sine squared and the cosine? Is there something we could do to make that cancel out, maybe?
1 minus cosine?
I'm liking that. So yeah, I think what we could do is we could change sine squared. I'm just going to move the negative sign out front. We can change sine squared to be 1 minus cosine squared.
Right.
We'll divide it by cosine. Oh, it did not work.
Because you're missing a parenthesis out in front.
Oh, okay. Thanks. There. No, it still doesn't want to do it. Oh, because this is all inside the thing here.
There you go.
There it goes. Okay, cool.
Yay.
Yeah, so changing sine squared into this, and then I can just divide each of these by that cosine. So this will be still the negative of the integral. 1 divided by cosine will leave a secant 2x. You know, cosine divided by cosine is just a single cosine. Secant is something that you have to look up on the integral table. Cosine we can do that. I don't know why I just put that there. Do you have the integral table on hand?
And you can break apart the integral.
Yeah.
Secant is the natural log of secant plus tangent.
I'm a little bit worried about the 2.
Yeah.
Feel 1/2 out.
Yeah.
Because you do use substitution to get this table 1/2 out. It's fine. We'll leave it like that. And then the negative cosine on the end would be negative 1/2 sine of 2x.
You're missing a bracket.
Am I again? Oh, yeah. There. Natural log secant 2x plus tangent 2x. Yep, okay.
Okay, so that whole chunk is our V1?
That's just V1, yeah.
Okay.
So what that means is that the particular solution now is this awful looking V1. I'm just going to copy paste it. So this awful looking thing times, so I'm going to scroll up. Remember that this was our particular solution here. So it's V1 times cosine 2x V2 sine 2x. So this awful V1 times cosine 2x.
My goodness.
Remember V2 was negative 1/2 cosine 2x. That times y2, which was sine 2x. Alright, so this whole parentheses here was V1. Cosine 2x was y1. Plus this was V2. And then this was y2.
My goodness. All right.
But I think it simplifies down. I at least combine these two terms together. right? Because they're both
Okay.
negative 1/2 sine 2x cosine 2x.
Okay.
And I feel like
Would the one on the left end up being positive since you've got the negative 1/2 in front? Like with those two, would they?
I probably messed up a lot. That negative sign, I forgot to distribute this negative sign
Oh, okay.
from here. So this
Uh-huh.
should be a positive,
Okay.
which means this is a positive, which means that these are
Okay.
nicer because now these two terms will actually cancel out instead.
Cool.
I think this is what we have left. Times cosine.
That's just a solution.
Yeah.
You just have to add it back to the others.
Yeah, so we have our homogeneous chunk and then our this chunk too.
So yeah, that means is adding those two things together. So that's that. C1, cosine 2x plus C2 sine 2x. That's the homogeneous stuff. Plus this thing. Let's see if that looks anything like that solution on the thing here. Remember we were doing this. Looks like it.
Yeah.
Yay, us.
You did most of the hard work. Yeah. You were just like, yep.
Yeah, those are hard. I would say on the test, I think there's maybe one of those.
Okay.
Cool.
But there's only, 10 or so questions, so.
There's
Yeah.
12.
12 questions.
Oh, okay.
That's what I got a question for you. You told us like Thursday that it was going to be mostly multiple choice.
I thought there'd be some multiple choice.
There was only, for me, there was only one, and the rest of them were really long problems.
Oh, were they?
Yeah.
I'll have to look at it again. I thought there were like 3 multiple choice questions on there.
I only had one, and I was not prepared for that at all, for the paper-wise. So, yeah, I sent you a message and everything.
Okay. I haven't looked at it yet. No, I thought I put like 3 multiple choice, but I did make it so that everybody would have different questions.
Yeah, I have
put them together.
really long questions.
Okay.
And it kind of randomized it so that like you just didn't end up with any of the multiple choice ones.
I tried to make it so that like each question had a pool of questions to it, and we're all the same type. I don't know where that.
Yeah, I was sweating bricks the whole entire test.
Oh no.
Please tell me you're going to give partial credit, because I made a lot of stupid mistakes.
Well, yeah, you put your notes up there, right?
What I had, because I had to use a whiteboard, I ran out of paper.
Like, physically you ran out of paper? You didn't have no paper with you?
No, I had like 3 sheets of paper, 3 or 4 sheets of paper.
Yeah.
Because I thought it was going to be...
I'll make sure I have extra paper. Yeah, me too.
It is only 12 questions, though. And I think I put a time limit of 3 hours or 4 hours.
4 hours.
4 hours.
4.
Yeah, so
that's part of the reason why it caused me to make a lot of stupid mistakes. I was like, I really hope I have enough time.
yeah. I only put the time limit on that because I didn't want people just opening up the test and then taking all day searching for solutions or,
Well, you can't close out of the test, so...
Yeah, like But I mean, like somebody could just open it up on their laptop and then search on their phone or put up a
True.
question, ask G.
We're honest. We don't think about that.
We still got some time though. Is there any other examples that you want to look at?
So we did a variation of parameters. We did
And that kind of incorporates most of everything else. You have to find the homogeneous and the particular and
The equidimensional one. The only other thing that we haven't done is undetermined coefficient stuff.
What about the super whatever?
Superposition?
Yeah, we kind of talked about that.
We did talk about it, but we haven't done one. I mean, technically we just did superposition, right? Because superposition is you find two separate solutions and add them together. That's pretty much what we just did.
Can we do one that has the non-homogeneous, where you have to solve for the
Undetermined?
Yeah, the undetermined, I'm sorry. Coefficients? If we have any examples?
Yes. That was section 4.4.
Yeah. How about number 8 here? Is that too easy? Not hard enough? So we'll make a harder one?
Number 8?
We can try it. I mean, if it's not hard enough, we can always pick another one.
Yeah.
I could try and look one up. What section was that on the homework? 4?
4.4, I believe.
That one's pretty bad.
Whoa, I recognize that.
Some of these.
That one looks difficult.
Yeah. Definitely not that one either.
Let's just have to look at E's. I'm kidding.
Hey, now we see what he gives us for homework.
How about this?
That one sounds cool. Yeah.
Alright, let me copy it to my workstation here.
So how will learning the other chapters work?
I've started making videos. You can find the first video in Moodle so far. And I can't think of any other way to do it except for just me sitting here recording as if I was teaching in a classroom. So then you guys would watch the videos. I'm going to try and only make them 10 to 15 minutes long, although the first one I made ended up being 20 minutes long so far.
I thought you were going to hold the classes on here like this. Did you pretty good at typing?
Yeah.
No.
I know. I'm actually impressed by your typing skills.
Yeah, you're really good.
I thought about doing that as well, but just with everything going on, I don't know if everybody would be able to make it at certain times.
Well, if you have it
Well, but you can record this, right?
I can, yeah. I was thinking about doing it at 6, Tuesday and Thursday, like before, and actually have it like a class time. But I know, with me right now, my kids are home, right? So I have to make dinner for them, and I have to make sure their homework is done, and they have time on the computer. And
yeah,
they're out of work right now, so maybe they have to work part-time. And I just don't know. And so I would hate to have to do that and people not be able to come and not show up. So I think I might just record the videos as if I am teaching it to you guys. And if I watch it, and then we have these sessions where people can come in and ask questions. I think that would be the easiest and best for me.
That makes sense.
I'll take that.
Yeah.
All right, so let's start with this question. So x double prime minus 16x prime plus 64x is equal to 5x e to the 8x. First thing that you always do to answer these questions, auxiliary.
All right.
So r squared minus 16r plus 64 is equal to 0. Maybe that can be factored. I kind of hope so.
Looks like
This
it.
should be fun. All right, so this factors into r minus 8 squared, which means that we're only going to have one solution, and it's a double root of 8. It is just a regular number, right? Not a complex number or anything like that, and a double root. So this is going to have solutions to the homogeneous C1 e to that power plus C2. This is where you have to throw in that extra variable. I keep putting T's, sorry. So used to T's in class. So C1 e to the 8x plus C2x e to the 8x. And the reason that extra x is there is because this is a double root.
Okay.
Now the undetermined coefficient stuff. This is where you want to find the particular solution to just that part when you have the function on the right-hand side. There was multiple different parts of the undetermined coefficient, and every single one of those parts had its own multiple set of parts, and it all depends on a lot of different things.
Right.
There are no cosines. Sorry. Oh, go ahead, Robert.
Is that like the A and B kind of thing?
Yeah, that's the A1, B1 stuff. Yeah.
All the different cases and all that.
All the different cases. There's no cosine and sine here, so that means we're looking at like part 1 of the undetermined coefficient thing. But the exponent here is an 8, which matches my double root down here.
Oh, yeah.
So when those match, you have to be a little bit more careful. This is actually part 1 case triple I. I don't remember exactly how we wrote it in class.
Yeah, we did the eyes.
I think. Okay. Part 1I, you had to have like this extra x squared out in front, or t squared, I think we put it in the way we wrote it.
Right.
Now you have undetermined.
I remember it that way just because since it's a double root, you have a squared in front. That's just an easy way for me to keep it straight.
Yeah. The function on the other side is a linear polynomial, which means that your undetermined coefficient, particular solution, needs to be the same thing. It needs to be a linear thing so just a1x plus a0, or however you want to label it, the exponential thing. Whatever your function is on the other side has to match your particular form for the undetermined coefficient. Linear, polynomial, and then the exponential. This extra x squared is just because our double root matches the exponent.
Okay.
All right, now you want to take this and plug that into the original equation.
Oh, yeah.
This is where you have to take the derivative twice. And plug it all in. I'm looking at it, and I really don't want to do it.
I know.
Yeah. Yeah, it's kind of gross.
That's what you're saying when you do the test.
Yeah. Yeah, unfortunately, like, there's just no way of getting around some of these really awful things. All right, so I multiplied the x squared,
Oh, okay.
squared in, and then I'm going to do product rule stuff. So this whole parentheses will be the first, e to the 8x will be the second. So I'm really going to cheat here now that I'm on a computer. I'm just going to copy this.
Oh, yay. You could copy and paste.
All right, so that parentheses times the derivative of e to the 8x, which is ae to the 8x, plus the second, which is the e to the 8x times the derivative of the first. Okay. And now we have to put the derivative again.
Lovely.
Yay.
We're going to have to do these 2 separate times. So this first thing that I've highlighted here, we're going to have to do a product rule there. First through to the second, second through to the first. So the first, just copied it. Derivative of the second is going to bring another 8 down, so it's going to be 64 e to the 8x plus the second derivative of the first. All right, plus this term, we need a product rule as well. All right, so first through to the second is going to be 8 down, plus second derivative of the first, which is second derivative of this function. All right. I know working on the computer here, that probably didn't look all that great to do it, and I had to do some stuff in my head, but I hope you guys are okay with just taking this thing's derivative. So just kind of, write this down and double check that you're getting the same stuff as me.
The two middle terms are the same.
They sure are. I think that's kind of designed. Yeah, we can combine these together. All right, we're not done though, right? Because now we have to take this and plug it back into the original equation.
Oh yeah, that one part.
So plug that in. I wrote things as y's. These should be x's. It doesn't matter. Plug it in. So it's going to be this awful looking thing here. Copy paste. Minus 16 times this awful looking thing here. Plus 64 times this awful looking thing here. All right, cool. Oh, and it's still equal to the other side. The, where was it? 5x e to the 8x.
Yeah.
All right, and now it's just a matter of combining like terms, being very, very careful with how you're writing stuff out, making sure you put brackets around everything so you know what gets distributed where and where to combine like terms together. Just to try to do that. Oh boy. I wouldn't. Like, if it was me, I wouldn't try to combine stuff together. I would just look at the different terms that are out there. So this is where you want to break this down into all of the x cubed terms, and then all of the x squared terms, and then all of the just the x terms. My spacing's all over the place, and all of the constant terms. So just kind of going through this and make sure we're distributing out the parentheses as we go. Anything that has an x cubed in it, we're going to write out into its own equation. So just starting off, it looks like I have a 60. Oh, and then all of the e to the 8x's just disappear, right? You can just divide e to the 8x from everything up here. So you can ignore those. So I'm going to have a 64 a1 x cubed. So this term is now done. Okay, and then my next x cubed is here. So it looks like I also have a negative, so we got to be careful. 16 times this 8 here, multiplied by this thing. What's 16 times 8? Does anyone have a calculator in front of them?
128. 128.
128. Okay, so negative 128 A1 x cubed. Oh, we don't have to put the x cubed. Sorry, I keep forgetting. It's just the constant coefficient on front. So 64A1 minus 128A1. All right, so now this one's done here.
And you got another 64.
And then over here we have another plus 64A1.
But wouldn't that come to 0 then?
It sure does. So, yeah, and with this equation, didn't help us. But it is what it is.
Okay.
All right, our x squared stuff.
Mm-hmm.
So we have a 64 A naught. We have an 8 times 3, 24A1. So we did this one. We did this one. 3A1. Oh, no, sorry, 24A1. Another 24A1. That's this term here. 3 times that 8. No x squared terms. This has an x squared term. Another negative 16 times 8 there. So negative 128 not. That's that term. We have a 3A1. This term. And then over here we have a 64A naught. And it's all equal to 0 since there's no x squared on the other side. We can simplify this down a little bit.
A naught would be 0.
A naught is 0. A1. I guess it doesn't matter. 51 A1 is equal to 0, which tells us that A1 has to be 0. Oh, I can't scroll. Okay. Now on my x terms. So let's see. We're done with everything here. Done. We're at this one. So we have a 16 A naught. I have another 16 A naught. I have a 6 A1. I have a plus 2 A naught. And that's it. And now this we have to be careful with, because this is not equal to 0. This is going to be equal to the 5
Oh, yeah.
from the other side. So hopefully this will give us the A naught here. Because A1 is 0, I can ignore that. 16 plus 16 plus 2, 34 A naught is equal to 5.
34.
34.
So that is going to be our A naught there. And there's no constant, or there is one constant here, but I don't know if it's going to help us. I feel like I messed up somewhere.
Or it's just horrible.
What is this, horrible?
Horrible. I feel like I might have made a little mistake somewhere in all of this stuff. But just to write it out now, that means that if I didn't make a mistake, my particular solution from here, the A1 is 0, so that's nothing. But then this A naught, that's the 5 over 34, x squared, e to the ax. So that's going to be my particular solution, plugging the A1 and the A naught back in up top here. And the final answer is combining these two things together. So it's going to be the homogeneous solution from up top here, C1 e to the 8x plus C2 x e to the 8x plus 5/34 x squared e to the 8x. So again, just the homogeneous plus the particular. For this particular, we got from the undetermined coefficients. And it was a gross one.
It was a gross one. I think they're all gross, honestly.
Yeah. He gives us all the growth on the first part.
Yo, but then the easiest super easy ones can throw you off too. You're like, wait, that's stupid. That was not even a question.
Yeah.
Oh man.
So can we try to put it in and see if it takes it? I know you're gonna have to switch some things around to see where it is.
No, I'm scared. So first, this wasn't asking for the entire solution. It was only asking for the
okay.
solution. So that would just be the 5/34 x.
And that would be t squared because I think it's got different variables.
You're right. No, enough.
Okay.
Oh, good.
Yeah,
At least we know the process.
we'll see what the actual answer is. Yeah, see, that wasn't off by much. I got that the A1 was 5/6 instead of, I got the A0 was 5/34.
Oh, okay.
So it was just some mistake here. The process was right. I think it's just because I'm doing it on the computer, like I can't actually write out everything.
Right.
It's just something to keep track of.
Just get your smart pad working.
Yeah. I didn't even realize we could do that. Multiply, like if you have a T, just go ahead and multiply that through. It makes it a lot easier.
Yeah, it saves you a little bit of work with the
Yeah.
I think we went over everything, didn't we?
I think we've covered pretty much everything that we're going to be using. Okay. I'm trying to do this.
When you go to do the test, though, make sure you have everything. I would still recommend writing out like a little cheat sheet.
Yeah. Okay.
Like a one-page, all the equations, all the different forms of the particular solution, and maybe even like a step-by-step for what to do for what problems.
Right.
And remember, Bilabs doesn't forgive.
My lab doesn't forgive.
Yeah, I've already looked at a couple. I think I even looked at yours test a little bit as well, Robert. So if there are things where you are like really, really close, I'll give you the majority of credit for the question.
My biggest thing was the negatives, carrying the negatives.
Mm-hmm. I've already seen examples of people typing it in exact and it still counted it wrong. So.
Yeah. It can be tricky. It can be very tricky.
Yeah, it can. And the homework too.
When you get your scratch paper for the test,
Okay.
upload the scratch paper open to Moodle and I'll look through it like I normally do.
That'll work.
Is there any other questions before we get
anything about like that overdamping and underdamping?
There may be something on there, yes, but all you need to know is what does it mean to be overdamping and what does it mean to be underdamping.
Like as far as like the graph, how the graph looks, or what it means as in.
By what the graph looks and what coefficients give you that. Like, what is it? Like, how do you know if it's underdamping? How do you know if it's overdamping? So, the graph, right? Underdamping means it continues to do this forever.
Right.
It's underdamped because it does not damp down. Overdamping is when you have that exponentially decreasing bounds, and then your spring goes back and forth, but only in between these bounds, and eventually it dies down to nothing. That's overdamping and underdamping. And then there's one other, like I forget what we called it.
Critical damping.
Yeah, so there's another one where it doesn't even do that at all. Like it will go up and it'll come down and it'll just stop.
Oh yeah, I remember those.
It is allowed to do one rotation and then stop, but no more than that.
Okay.
Okay. Think I can do it. So the test is due before 12 midnight tomorrow.
Yes.
Okay. All right.
And then, so for Thursday, is that just going to be another question session like this since you've posted the Chapter 5 stuff, like those recordings, or?
I'll probably still do it. I don't know if people are even going to have time to start Chapter 5 at that point. I would hope so. The one on Thursday, which remember it's during the day. It's not at 6, it's at 11.
Right.
Yeah, it's basically going to be getting past Chapter 4, and we'll start looking at the Chapter 5. So if you guys have questions from the Chapter 5 homework, then that's what I'm going to ask there.
So, sir, I sent you a message real quick. I didn't want to say it out loud.
Okay.
Oh, yeah. So there is a question on there. With this kind of thing, the overdamping and underdamping stuff, it's not asking you for if it is overdamping or underdamping. It's basically going through the method of the question and then asking you what the math would have to be. So just remember that when you have a spring, the spring is in this form.
Right.
Y prime plus B, this. I can't say it and type it at the same time. Right, so your mass, your damping, and then the spring constant. So there is a question that gives you, not this necessarily, but gives you a scenario, and you have to figure out what the mass is. Just know the mass is the number of.
Okay.
My screen went. Oh, right, there we go. Okay, it does have some time. Okay, cool.
All right. Other than that,
So we just need to know how the math kind of fits into that.
yeah, I don't want to give it away too much, but yeah.
Right.
Just make sure you get the general concept of not just solving the differential equations, but knowing
What it means.
and what it means as far as the spring goes.
Okay. I can do that. Great. Thank you, Mr. Weaver.
Yeah, of course.
Yeah, thank you.
See you right Thursday. If you have any other questions, just send me an email.
Okay. Sounds good.
Sounds good.
All right.
You guys have a good evening.
You too.
Yeah, you too. Bye.